Calculus is the mathematics of continuous motion and change, the hidden engine powering artificial intelligence, global finance, and modern spaceflight. But before you can calculate the exact instant a rocket hits maximum acceleration, you need to verify your mathematical foundation is absolutely solid. Over the next 5 minutes, we are going to complete a Phase 0 readiness audit. Together, we will evaluate your grasp on 4 core math pillars and build a daily practice plan to fix any weak spots. Grab a piece of paper right now. Draw a line straight down the middle and label the left column Mastered and the right column to Review. Establishing this baseline today is the only reliable way to prevent hitting a wall of frustration when you step into Phase 1 of actual calculus. At the top of your paper, write down the 2 main branches of calculus: differential for rates of change and integral for total accumulation. Differential calculus is used to figure out exactly how fast something is changing at a single frozen instant in time. This diagram shows water flowing into a bucket on the left, paired with a car's speedometer on the right. The flow rate of that water, or the exact speed of the car at this very second, is differential calculus in action. Integral calculus, on the other hand, measures total accumulation over time. Notice the rising volume of water pooling at the bottom of the bucket, or the total miles ticking up on the car's odometer. These 2 perspectives, the instantaneous rate and the total accumulation, form the 2 distinct lenses that calculus eventually uses to analyze physical systems. Let's begin the actual audit. Step 1 evaluates your arithmetic and fluency with basic mathematical symbols. Look at this math interface. Test yourself mentally. Can you confidently add fractions like 1/2 plus 1/3 to get 5/6? Or quickly calculate 25% of 80? If those feel automatic, you can check off the first 2 items on our list. A common mistake is confusing an expression, like 3x plus 2, with an equation, which includes an equal sign. An expression represents a quantity. An equation defines a relationship to be solved. Next, test your algebraic reflexes. Watch as the interface factors a quadratic equation step by step. You need to be comfortable solving standard linear equations and factoring quadratics to find the values of x. Log your results on your paper. If you felt confident through these examples, check off items 1 through 4 in your mastered column. If you hesitated, put them down into review. Algebra provides the essential notation required to translate physical movement into a solvable mathematical model. Moving to step 2 of the audit, we need to evaluate your geometry skills, specifically how you measure space, shapes, and angles. This graph displays a line connecting 2 points on a Cartesian plane. You must calculate the rise over run slope and apply the distance formula. Watch this line become a right triangle's hypotenuse. You must instantly recognize how to find sine, cosine, and tangent using the opposite, adjacent, and hypotenuse sides. This triangle scales to form the ultimate trigonometry tool, the unit circle, with a radius of 1. Calculus relies strictly on radians. As the highlight sweeps a half circle, you must know intuitively that 180 degrees equals exactly pi radians. Take a second to update your paper. Place items 5 through 8 in your mastered or to review column, depending on your comfort level with slopes, triangles, and radians. Without an intuitive grasp of slopes acting on a graph, or angles moving around a unit circle, calculating derivatives will be impossible to visualize. With the diagnostic portion complete, let's build a daily system to fix every gap we just identified. On the back of your paper, write down this 2-hour daily practice plan. You will use this exact structure to clear out your to-review list. This chart maps out a standard 2-hour block. Start with a 20-minute wedge to review yesterday's concepts. Follow that with a 40-minute wedge focused strictly on learning a new topic, and then a second 40-minute wedge dedicated to solving practice problems. Notice the final 20-minute wedge filling in now. Do not skip this step. Taking time to revise your formulas and make clean notes is required to lock these rules into your long-term memory. Applying a strict time-blocked schedule takes an overwhelming list of mathematical weaknesses and reduces it to a completely manageable daily checklist. Look down at your paper. You now possess a complete, highly personalized Phase 0 skills map. The value of this audit is knowing exactly which tools require sharpening in your toolkit before you start the heavy lifting of Phase 1. Your final step is simple. Run every item in your To Review column through that 2-hour daily plan until your entire list moves to Mastered. Mastering these foundational skills allows you to move directly into Phase 1, where you will begin working with functions.